Welcome to Lecture 8.4, More Quadratic Equations. So let's review solving a quadratic equation by factoring. For example, we have x squared minus 16 equals 0. Those are perfect squares, so it's the difference of perfect squares. So I have x minus 4 times x plus 4. Set each of them to 0. Each of our factors to 0, so it's x minus 4 equals 0, x plus 4 equals 0. Solve each equation separately. Therefore, I have x equals 4 as well as it equals negative 4. Let's try another example. Now just recall that this is not teaching you how to factor quadratic equations. We did this earlier in class, so if you do need to go back to see another lecture, scan the list of lectures to see where we did factoring, which I believe it was in Chapter 5. So any of the videos on 5.1, 5.2, and so forth will help you learn how to factor quadratic equations. So let's first set this equal to 0, so I need to move the 12 to the left-hand side, so I subtract 12 from each side. Now I factor the 2x squared minus 5x minus 12 into 2x plus 3 and x minus 4. Set each of those equal to 0 and solve for x. So I have x equals negative 3 halves and x equals 4. Let's solve, pardon me, 16a squared minus 25 equals 0. Again, two factors that multiply would be 4a minus 5 and 4a plus 5. Solve them and I get a equals 5 fourths and a equals negative 5 fourths. Solving a quadratic equation by factoring isn't always the easiest way of solving the equation. So we're going to teach you a new method, and that is completing the square. So here's what we think about. Let's consider x squared equals 16. Well, then the square root of x will equal either the square root of 16 or x will equal negative square root of 16. Because I have a positive root and I have a negative root. If that's the case, x equals 4 or x equals negative 4. That was a lot simpler than moving the 16 to the left-hand side, then factoring, then breaking it apart each into individual equations to solve that equals 0, and then solving for x. Now we have a new property that we can use, the square root property for equations. For all positive real numbers b, if a squared equals b, then a will equal the square root of b, or a will equal the negative square root of b. So the shorthand to this is a equals plus or minus the square root of b. It's both the positive and the negative root. For example, let's solve for x. X squared equals 5. Using our property, I can say x squared equals 5. Take the square root of both sides. It is a mathematical operation we're using. Square root of x squared is x. The square root of 5 will be plus or minus the square root of 5. So my solution set is going to be negative square root of 5 and positive square root of 5. Another example is 5a squared equals 60. Well, the first thing I want to do is divide each side by 5 so I can get a squared all by itself. So a squared now equals 60 divided by 5. But 60 divided by 5 is just 12. Now I'm going to take the square root of both sides. So a will equal plus or minus the square root of 12. But the square root of 12 is not in simplified form, so we do want to put it in simplified form. 12 would be 4 times 3. 4 is a perfect square, so it's going to be the plus or minus the square 2 times the square root of 3 will be our solution. Let's solve for y. We have the quantity y plus 4 squared equals 25. But if I take the square root of y plus 4 quantity squared, and take the square root of 25, I can get rid of this squaring property. So the square root cancels out the squaring, leaving me with y plus 4. The square root of 25 is plus or minus 5. Now you might ask, why didn't we do the plus or minus 5, or the plus or minus y plus 4? It's because that quantity was being squared, so the positive value is going to come out, if that makes sense. Right? So now that I have y plus 4 equals plus or minus 5, this is two solutions, so I do need to break this equation apart. One becomes y plus 4 equals positive 5, or y plus 4 equals negative 5. Solve each of these equations. Subtract 4 from each side, y equals 1. Subtract 4 from each side, y equals negative 9. So my solution will be 1 or negative 9. I have two solutions. If I was going to try and solve this by factoring, first I would need to expand y plus 4 squared. So I have y squared plus 8y plus 16 equals 25. Bring the 25 over. So I have y squared plus 8y minus 9 equals 0. Factor it, y plus 9 times y minus 1. Break it apart into individual equations set to 0. Y plus 9 equals 0. Y minus 1 equals 0. Solve each of them. So y equals negative 9. Y equals 1. We came up with the same solution, just different method. Okay, let's try another one. The quantity 2x minus 3 squared equals 25. I'm going to take the square root of both sides. When I take the square root of a square, it cancels it out, leaving me 2x minus 3. I get the plus or minus the square root of 25 will give me plus or minus 5. Set each of them equal to each of the, set the 2x minus 3 to 5 as well as to negative 5. Sorry. So I have two equations. 2x minus 3 equals 5. 2x minus 3 equals negative 5. Solve for x for each of the situations. For the first situation, x is going to equal 4. Second situation, x equals negative 1. So my solution to this equation, this quadratic equation, is 4 and negative 1. All right, quantity 4y minus 5, quantity squared, equals 6. Okay, first thing I'm going to do is take the square root of both sides. That will give me 4y minus 5 equals plus or minus the square root of 6. Break it apart. 4y minus 5 equals positive square root of 6. 4y minus 5 equals negative square root of 6. Add 5 to each side, and then divide by 4. So add 5 to both sides, then divide by 4. Now your solutions are going to be, if square root of 6 is approximately 2.14, you can plug that in and y will be approximately 7.45 over 4 and 2.55 over 4, giving us y is approximately 1.86 and approximately 0.64. Now remember, these are approximation because the square root of 6 is an irrational number, so we're approximating it. All right, so here's what I'd like you to do. This is your problem to complete and bring to class. We have the quantity 2x plus 6 squared equals 8. Using the methods that we did in the previous examples, go ahead and solve this and bring this to class in our next session. All right, I'm going to change things up and go back to geometry a little bit and talk about two very special triangles. One is where we have the angles. It's a right triangle, so one of my angles is 90, but my other two angles, one is 60 and one is 30. The second special triangle, I have a 90-degree right triangle, but my other two angles are 45. So the first triangle is called a 30, 60, 90 triangle, and the second is a 45, 45, 90 triangle. That's generally what they're called. The sides of the 30, 60, 90 triangle are in the ratio of 1 to square root of 3 to 2. So if I was to put a 1 here, square root of 3, the hypotenuse would be a 2, would be length of 2. The sides of the 45, 45, 90 triangle are 1 to square root of 2. So how can we use that information to solve a problem? If the shortest side in a 30, 60, 90 triangle is 1 inch, we want to find the lengths of the other two sides. Now, if we didn't know what our ratios were already, here's how we can solve it. I know that I have a right triangle with the length of 1. I don't know what this length is, and I don't know what my hypotenuse is yet. Right? I don't know. What I'm going to do is I'm going to build a big triangle, and now I know if I double the length of my short side, all of these sides are going to be the same dimension. So across from A to D, where A to C was 1, A to D is now 2. And if A to D is 2, I can create a line from D to B to equal 2 and B to A to equal 2. Well, lo and behold, I just found my hypotenuse of my 30, 60, 90 triangle. Right? So far I have 1 for one of my legs and a 2 for my hypotenuse. Using Pythagorean Theorem, I know that x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. Subtract 1 from each side, so x squared equals 3. But remember, take the square root of each side, it's going to be x equals this plus or minus the square root of 3, but since we're dealing with length, we can ignore the negative square root of 3. So the length of the height is square root of 3 inches. Here's a problem that includes a triangle. So Forrest double chair lift has a 1,170 feet vertical rise, and the length of the chairlift is 5,750 feet. To the nearest foot, let's figure out what the horizontal distance will be. For example, or for instance, here's the vertical rise, here's the length of the lift. If you think we're going up a mountain like a ski lift, we can use Pythagorean Theorem to figure out what x is. So by setting it up, AC, this length of my horizontal distance, squared plus the vertical rise distance will equal my hypotenuse squared. I plug in the values that I know. X squared plus 1170 squared equals 5,750 squared. I know they're big numbers, but calculator will take care of that. So if x squared equals 1368, 900 equals 3306, 2500. Subtract, and now x squared will equal 31,693,600. Take the square root of both sides. Again, it's going to be plus or minus, but since it's length, we can ignore the negative. So x is going to equal 5,630 feet, rounded to the nearest foot, mind you. So that's it for this lecture. So until next time, be seeing you.